All right, so the task that's going to be laid out for us is to find the circumcenter of this triangle. Now, yesterday at the end of the period, we showed an example where the ordered pairs that they gave us lined up conveniently to where they gave us a set of vertical and horizontal segments. Therefore, you had a right angle. If we have a right angle, then the circumcenter shows up where?
On the midpoint of the hypotenuse.
The midpoint of the hypotenuse. Now, we could still have, this could still give me a right triangle, but the orientation of this triangle is not going to have any vertical or horizontal lines. So it might be hard for us to decipher just by looking at it whether it's a right triangle or not. And even if it's not a right triangle, which I don't think it is, we would still have to come up with all this information to find the circumcenter. Now, I know it seems like a lot of material here. So it seems like a lot of material, but I tried to provide you like guided notes for this. This is the procedure that you would go through every single time when they ask you to find the circumcenter if it's not a right triangle. Generally speaking, so if I gave you this on Math Excel, what Math Excel does, like they give you that's the question. And then they give you a box that says, type in the circumcenter, okay? But then you have to go through all of this work to do that. So I want to kind of walk you through this procedure. Now, all this algebra that is involved here, we've done, okay? So I'll plot the points. Hopefully you've already done that. So 4, 2. And really, to be honest with you, the graph is strictly just for like graphic organization. So that I know what segments to deal with and which ones to bisect and that kind of stuff. So 6, -4. I think it's a good idea as you are graphing this that you label things so that you don't have to come back and recount ordered pairs and stuff like that. So that is my set of points. I'm going to, all right, so we connect the vertices, we got that triangle, right? We're trying to find the circumcenter. So the circumcenter is found by locating the segment bisectors of that triangle, okay, of those sides. So what we're gonna do, step 1 here says finding the perpendicular bisector of AB, okay? So first thing we have to do to find a perpendicular bisector, we're going to write an equation. That's essentially what we're trying to do here. Write an equation for the perpendicular bisector. First thing we have to do is find the slope of AB. So if I find the slope of AB, that is going to be, I'm going to take my y values. So it's y2 minus y1 over x2 minus x1, right? So I'm going to look at those two. So I'm going to go -4 minus 2, which gives me -6. And then I'll go 6 minus 4, which gives me 2. So we get -3, right? Okay. If you want to I think it's a good idea to double check that because we've got it graphed. So let's see what our rise or run is. Down 1, 2, 3, 4, 5, 6. So down 6, so -6. And to the right, 1, 2, so +2. So -6 over 2 does give me -3. Okay? Now, if I want to find the perpendicular bisector of AB, AB's slope is -3. What is the slope of any line that would be perpendicular to that? It's going to be 1/3. Okay, so this is -3 over 1, right? So anything that is perpendicular to it is the opposite sign. So there's the positive, but then it's also the reciprocal. So it's going to be 1/3. So the slope of the perpendicular bisector of AB is going to be 1/3. Okay. Now, what do you need when I write the equation of a line? You need the slope of that line. You need one other thing about the line. Let me know what one other thing you need. Okay, you need a point. And it doesn't have to be the midpoint. Okay? But if I'm just going to try to find the equation of that red line up there that I drew in, I need the slope of which we have, right? And I need one point that is on that red line, okay? Now, of all of these, and I just kind of haphazardly drew this red line, so I don't know any of these points that are on that red line. Does that make sense? Okay, but that red line, by definition, is a perpendicular bisector, right? So what Jagger is saying is, I should know that on that red line lies the midpoint of that line, right? Does that make sense? Okay, so if I can find the midpoint of that green line now, you guys remember the midpoint formula is taking your x's, add them together, divide by 2. Take your y's, add them together, divide by 2. So my x's added together would give me 10. Divide by 2 gives me 5. My y's added together would give me -2. Divide by 2 gives me -1. Does that point right there, 1, 2, 3, 4, 5, down 1, does that look like it's in the middle of A and B? Okay, so now we have our slope for the red line, and we have a point that is on that red line. So that's what this next thing says, part D. It says, using part B as M and part C as Y1 and X1. So that's your X1 and that's your Y1. Along with this formula, if you guys remember, Y minus Y1 equals M times X minus X1. We're going to plug that information, M and X1, Y1, into this. Okay, so it's going to be Y minus -1. So that's your Y1. Slope is 1/3. And it's going to be X minus 5. I'm going to solve for Y, so it becomes Y equals 1/3 X minus 5/3 minus my 1. So at that point right there, all I did is I moved the 1 over and I distributed at the same time. Now combining like terms, I get Y equals 1/3 X minus 8/3. That's, I got a common denominator, right? So that's 3/3. -5/3 minus 3/3 is 8/3. Okay. Now, I just want to take a moment, whether we use Desmos or GeoGebra. I like GeoGebra. Desmos, you can graph things like lines and segments and stuff like that. It's just kind of, I think, a pain in the butt. GeoGebra is a little bit more user-friendly in regards to graphing. So all I want to do is graph AB. I'm going to graph segment AB. So 4, 2, and 6, -4. Okay, if I connect those, I get that segment right there. We said the midpoint should be at 5, -1. That looks accurate, right? And we just came up with the line that said Y equals 1/3 X minus 8/3. And all I want to do is make sure that that goes, so does that go through the midpoint? And if I click on those things, does it show me that they're perpendicular? So we just found the perpendicular bisector of AB, all right? And if you can do that one time, then you can complete this problem without any issues, because the next thing that we do is the exact same procedure, but we do it for segment AC now, okay? So we're going to walk through. Actually, I want you guys, from what we just did, I know we might run into some issues, okay, but see if you can go through A, B, C, and D on the perpendicular bisector of AC on your own, or with the people that are close to you, and we'll then reconvene in a couple minutes and see if we were successful in that. If I want to find the slope of AC, okay, I'm going to take 2 minus -2. 2 minus -2 gives me 4. And then we'll go 4 minus -2. So 4 minus -2 gives me 6. Did you guys get 2/3 for that slope? Okay, so that's the slope of the AC. That's the segment in the triangle over here, okay? And again, in this situation, if I count rise over run, 1, 2, 3, 4, and then over 1, 2, 3, 4, 5, 6, 4 over 6 gives me 2/3. Now, I would encourage you maybe to count to validate your algebra, but there will be times where these integers are fractions, and then counting is an impossibility, okay? So it's good to rely on the slope formula. Now, if that's the slope, what is the slope of the line that is going to be perpendicular to that? 3 over 2, and it should be negative, right? Always got to take the opposite sign. Okay. Now it says find the midpoint of AC. Well, finding the midpoint of AC, we're now going to add these two numbers and divide by 2. So if I add those, I get 2. Divide by 2, I get 1. And I'm going to add these two numbers, gives me 0. Divided by 2 gives me 0. So 1, 0 should be the midpoint. If I look at this graphically, there's 1, 0. That looks like my midpoint. And we know the slope should be down 3 to the right 2. So if I go down 3 to the right 2, that black line right there is the perpendicular bisector that I'm trying to find. Does that make sense? Okay. So then, with this being M, and this being X1 and Y1, we're going to plug into Y minus Y1 equals M times X minus X1. It's going to be Y minus 0, so that's just going to be Y, equals M, which is negative 3/2, X minus 1. That's going to generate the equation Y equals negative 3/2 X plus 3/2. Did you guys get that? Put a bubble around it. Now, just to confirm that, let's just go and graph AC real quick. So I'll hide that segment. I don't really want that to be C. Let's rename that to D. So hide that, hide that, hide that. And C was at what? Negative 2? Negative 2? So I look at that segment. We said we anticipated the midpoint to be at 1, 0. So if I click on the midpoint of AC, it does give me 1, 0. And then we came up with the equation Y equals negative 3/2 X. Was it plus 3/2? Plus 3/2. And it goes straight through E, goes through my midpoint. And are those perpendicular? That's showing 270 there. So if that's 270, then this angle here's got to be 90, right? Okay. You click here and there, and it'll put that 90 in there. All right, so what we just came up with in the equation of that is the equation of the perpendicular bisector of AC. So now here's my question. And we're going to go one more practice at this. But if I graph the perpendicular bisector of AB as well, does the red perpendicular bisector and the blue one, do they cross? So where they cross is actually my circumcenter. Okay. Now, if you look at this is where, because this is not a right triangle, we run into some issues. That point of intersection right there is not a real nice number, either ordered pair or either coordinate of the ordered pair. Now, there should be, and we're going to do this just to validate this, but there's a third segment that we have not talked about. We have not found the perpendicular bisector of that one. In all practicality, we don't need to, because if 2 of the perpendicular bisectors intersect, then all 3 are going to be concurrent. But I think it's good practice to to find the slope of BC. So finding the slope of BC, we're going to go -4 minus -2. With questions like this, just make sure if you got a lot of negatives and you struggle with subtracting negatives, that you write it out, because I think that's more obvious. -4, and that's going to be +2. So my numerator is going to be -2. And then I'm going to have 6 minus -2, so that's going to give me 8, right? So -1/4 is the slope of BC. Again, can I count that? Down 1, 2, and then over 1, 2, 3, 4, 5, 6, 7, 8. So that is confirmed. What is the slope then of any line that would be perpendicular to that? If -4 is the slope, what's the opposite sign to reciprocal?
-4 over 1.
Just 4. You gave me the reciprocal, but then we need to negate it. We need to find the opposite sign of it. So flip it would be -4, and then opposite sign would be +4. Okay. Now we want to find the midpoint of BC. So the midpoint of BC, you're going to add these two x's together and divide by 2. So that'll give me 2. Add these two x's together, or sorry, add these two y's together, divide by 2, and it gives you -3. So I'm just going to plot that real quick on my picture. 2, -3. Is right there. Does that look like it might be the midpoint? And we'll be now looking for the equation of that black line. To find the equation of that black line, this is going to be the m that I use, and this is going to be x1, y1. So y minus y1 equals m times x minus x1. My hope is that you see that once we did it one time, once we find one perpendicular bisector equation, it's just repeating the process with different numbers to get the other ones. So y minus -3 will be y plus 3. M is 4. And then x minus 2. So it's going to be y plus 3 is equal to 4x minus 8. Subtract 3 from both sides. I get y equals 4x minus 11. This 3?
Yeah.
Because when I go, because this was the midpoint, right? So we've got y minus y1. So y1 is -3. So it's going to be y minus -3. So it becomes +3. So those right here, all I wanted you to do is to gather those 3 equations that we just developed. Okay, so you write those down. Just to confirm, if I type in y equals 4x minus 11, does that look like it passes through the midpoint of CB? It does. And do we have right angles there? And we do. There. Oh. So we get 90 there. Just a second. So that purple line is then the perpendicular bisector of B to C, or C to B, however you want to view it. The one thing that I think is important to realize here, our overall goal is to find one ordered pair. There's a lot of work here, right? There's a lot of places where you just miss one sign, you miss just one value, it throws everything off, okay? So this is a practice of paying attention to detail. It's a practice of making sure that we don't try to fly through something, because when we try to rush something, we make those little mistakes. And it's also, I think, a good practice because as we're doing it by hand, we're then using some technology to confirm what we've done, okay? So just kind of reiterate again, using the technology here. If we started with that triangle right there, okay? What we have done is we find the perpendicular bisectors of those three segments. So those perpendicular bisectors ended up being those. And those are the things that we came up with by hand. Those are the equations that we have by hand. Would you agree that all three of those intersect at the same point, the same location? Okay, we want to find that point. So if I want to find that point, okay, it is like any other set of lines that we've ever come in contact with throughout Algebra 1. If I have those two lines, we should be able to create, either through elimination or substitution, the location of where they intersect, okay? Or if I use those two lines, I should be able to do the same thing. Or if I use those two lines, still be able to do the same thing. So what we're going to do is we're going to create a system of equations that is going to allow us to find that intersection point. So at this point, and this is what I was saying earlier, is because all three lines are concurrent, you only need two of them. Okay? So if we never went through and found this last one, you would use these two, and you would set up a system of equations. Okay? But since we have this last one, we did find it, we can use any two of these that we want. Okay? Let's just go ahead, just for maybe practice of this, let's use that one and that one. I think sometimes maybe using ones that are not all that convenient looking, we got some fractions, allows us to practice some work with fractions. So we got these two equations. If y is equal to 1/3 x minus 8/3, and in this equation y is equal to negative 3/2 x plus 3/2, if we go back to our graph, we're asking where do these two lines intersect? So where these two lines intersect, these y values have to be the same. Does that make sense? Then if those y values have to be the same, then that thing right there, that is the rule that generates that y value, and this thing right here, which is the rule that generates that bottom y value, they have to be the same, correct? That's the substitution technique that we've used in Algebra 1. If these y's are the same, then the algebraic expressions that create them have to be the same. So I'm just going to write 1/3 x minus 8/3 should equal negative 3/2 x plus 3/2. Now this is why I wanted to use these two equations. Got a lot of fractions up there, right? How can I get rid of those fractions?
Just multiply.
Okay, so I'm going to find a least common denominator. So what is that least common denominator going to be? 6. So what I want to do is I want to multiply every single thing up there by 6. So I'm going to multiply this by 6. It's going to give me 6/3, which reduces to 2, right? If I multiply this one by 6, okay, it's going to give me, what is that, 48 over, no. I think you guys have the algebra to know that I can cancel that 6 with that 3. It leaves me 2. It gives me 16. Does that make sense? 2 times 8 then gives me 16. If you want to go 6 times 8 gives me 48, and then I have 48 over 3. 48 over 3 will also be 16, right? Okay. If I multiply this one by 6, okay, I can either cancel the 6 and the 2 and gives me 3, and go 3 times negative 3 gives me negative 9. Or you can take the 6 times the negative 3 gives you negative 18, and divide negative 18 by 2 gives you negative 9 as well. Multiply this one, 3/2 times 6 turns into just a positive 9 in that case. So that cleans things up, right? That makes our, instead of working with an equation with nasty fractions, that cleans it up. Ultimately, what we find out algebraically is that as long as you multiplied everything by 6, this thing still is identical to this thing. Okay? So now can I solve for x? Okay, so I'm going to add 9x to both sides. And I'm going to add 16 to both sides. So it gives me 11x equals 25. So then x will be 25 11ths. Now that's an ugly number, right? And there's no way around it. Most of the time, the circumcenter is not going to be a real pretty ordered pair. Okay? Now, we have to find the y value. We have to find the y value that pairs up with this x value. So we can plug this x back into one of those two equations. We can actually plug it into this one as well if we wanted to. But we have to plug it into one of the equations that we know passes through the circumcenter. So I'm just going to plug back into, let's go back into this bottom one. Or this middle one, I guess. So y will equal negative 3 halves times x, which is 25 11ths, plus then 3 halves. How do I multiply fractions? If I'm multiplying fractions, it's straight across the top. So what's that give me?
Negative 75.
Negative 75. And then you multiply straight across the bottom. Gives you 22. So negative 75 20seconds. And then I need a plus 3 halves. Now if I'm going to add, because I heard this when I asked to multiply. If I'm going to add them, what do I need? I need a common denominator. So what's the common denominator going to be between 22 and 2? 22. It's the number that you need, when we say common denominator, it's the number that they both are going to grow to through multiplication. So I need to multiply this one by 11 over 11, right? That'll turn that into 22. So it turns this into negative 75 20seconds, plus 33 20seconds. And what's negative 75 plus 33? Is it 47?
No, it has to be an 8. I'm just kidding. I was stupid.
I just did it on my calculator.
I thought it was a negative. 22.
Over 22?
It has to be a 2. I added them.
I was thinking it was 80 or something. Not 75.
So is that we could reduce that, right? What's that what goes into both those? 2. So we get 11, and then what, 21? Negative 21 11ths. Okay. So the x value was 25 11ths, right? The y value is negative 21 11ths. Would you have ever guessed that by just looking at where those two lines, the red one and the blue one, intersect? Okay, but if I plot this, if I go, you shake your head yes, 25 11ths, comma, negative, what do we say, 21 11ths? Point G.
Why can't it ever be so easy? Like, why can't it be easy?
So, eventually, we're running out of time today, we could determine what the distance from G to B would be. Okay? If I want to find the distance from G to B, just kind of, you don't have to write this stuff down, but just kind of watch how we would do this. So G, let me just come up here and grab one of these pictures. So G, we said, look, was located about right there. It was 25 11ths, comma, negative 21 11ths. If I want to find that distance right there, which that's the distance to each vertex, right? That black distance right there should be the same as that distance, which should be the same as that distance. Do you guys remember the distance formula? Being the square root of x2 minus x1 squared plus y2 minus y1 squared. Remember doing that? Okay, so I'll just do this math for us real quick. X sub 2, I'm going to say is the 25/11ths, minus X sub 1, which I'm going to say X sub 1 was the 6. We'll square that, plus then Y sub 2, which was negative 21/11ths, minus then negative 4. And we'll square that. So I'm going to, just to save time here, I'm going to cheat with GeoGebra, or not GeoGebra, Desmos. I don't know if you guys, it kind of stinks because it's not a tool that Desmos allow, or that the end of course exam allows us to use for Desmos. But if we take these values, so I could take 25/11ths minus 6, square that, add to it negative 21/11ths, which this is stuff we should be able to do by hand, plus 4, square that. Okay, I just want to make sure it was plus 4. Okay. So most of your calculators are going to give you that back as a decimal and have no ability to change it. Desmos has this little bubble here. You can change it to a fraction. Okay, so that right there, the square root of 2210 over 121, that is that distance right there. Does that make sense? Okay, so if we, just going to double check this in GeoGebra real quick. If I go square root 2210 over 121, gives me that number 4.274. If I ask it to measure that distance G to B, 4.274, right? Okay. Now, here's what is going to be nice once you guys learn a little bit of Algebra 2, is that we can actually, every circle has an equation. A circle has an equation that is going to be, we call it x minus h squared plus y minus k squared equals r squared, okay? So that's the formula for every circle we ever come across. But h is the x-coordinate of the center of the circle. So in this case, it's going to be that 25/11ths. Does that make sense? So I'm going to put 25/11 there. And y minus k, the k value there, is going to be the y-coordinate of that center. So in that case, it is negative 21/11ths. And r, what do you think r stands for in the equation of a circle? The radius. The radius for us was this distance, 4.274, right? So what that's going to be when I square that, it's going to be 2210 over 121. Does that create, when I type that in, does that create that circle that then circumscribes that triangle?
Yeah.
Does that make sense? So my hope is that we see here, obviously I'm not going to have you do the equation of the circle right now. I'm probably even going to be very limited on the amount of writing the equations for finding the circumcenter, okay? But I think it's a good practice to open your eyes to the idea that Algebra 1 and geometry are inherently linked, okay? Without one, we don't really have the other, okay? They go together hand in hand all the time, okay? No homework. Got an email, said that they are going to start working on student computers tomorrow. So hopefully,
They were when